Okay, so guys, yesterday we did and completed series circuits. So today we're going to go through parallel circuits. All right, this is from the notes that were posted last week. So the more devices that you add in, it's not going to wind up decreasing the overall current. So the bulbs aren't going to get dimmer as they would if you added more bulbs in a series circuit. And that if one of the resistors or one of the bulbs breaks, the rest do not go out. Now the current's not going to stay the same. It doesn't always stay the same for the entire circuit. There's going to wind up being basically drops. So there's multiple paths for this thing to take. So they're going to wind up getting different current across different resistors. And with that, it's going to wind up basically increasing our current flow. So it's not going to wind up slowing it down anytime we add more resistors in. Okay, so when we add resistors in, so this is just a basic schematic drawing down here of a parallel circuit. You have a battery, you have one path here, you have another path here. So you see how they're not all on the same path. If that's how it looks in the drawing, then you're looking at a parallel circuit. Now, resistors, right? Added by style or added by, side by side, more paths, all right, the less total resistance. So the equation for this is it's the inverse of your total resistance, which is going to equal, all right, each of the inverses of these guys. So if you have R1, R2, and R3, or however many you have, you're doing 1 divided by those values, get a number, and then you're going to do the inverse of that decimal. We're gonna take a look at a couple of different examples. So in a parallel circuit, the charge gets divided up. So one branch can have more current than another. But when we figure out what the total current is, that's going to wind up equaling the current that goes through each of the branches. So like in a series circuit, we had voltage drops across each resistor, and that the V1, V2, and V3, when you add them all together, it equaled the total, or the battery value. Well, in a parallel, we're kind of doing that with current instead. So in a parallel, current's not the same everywhere. You have to do you add them up to figure out your total. Now the voltage. So only charge passes through a single resistor. The voltage drop across the resistor that it chooses to pass through must equal the voltage of the battery. So the total voltage equals the voltage across each individual resistor. So if you had a 10-volt battery, V1 is 10, V2 is 10, V3 is 10. However many resistors you have, okay, they would all wind up having the same voltage going through that. So here are our equations. Now, in certain things, you may see, all right, RT here, total resistance as equivalent resistance. The equation is the exact same. I just been using RT before, so I'm going to use it again. So here's our first example problem, and I have the solution to this. So we're going to take a quick look at that. All right, so we're going to play this video that walks through that example problem.
All right, guys, so this is how we're going to go about solving a series circuit. I'm sorry, parallel circuit. We're still going to use Ohm's law, but the rules are slightly different. So in a parallel circuit, the voltage and the voltage drops are going to be the exact same. So if you know the battery, V1, V2, V3 are all the same. The current, though, is going to be different because it's got different paths it can take. To find the total current, you're going to add up all of them. I1, which goes through R1, I2, which goes through R2, and I3, which goes through R3. Now, to find the total resistance. Total resistance, sometimes called REQ. whole thing is very simple. I would say let's go about it first over here. So while we're doing that, we have R1, R2, R3, right? So because we have to take the inverse of these things added together, plus R3. Dot means if we have more, we're going to do more. So we have 50 as our first guy, so I would do 1 over 50 plus 1 over 100 plus 1 over 100. Now, this can be done 2 ways, right? So if you did this in a calculator, 1 over 50, get this guy plus 1 over 100 plus 1 divided by 100. And you're going to get this decimal. But it's going to, you have to do basically 1 over that answer, right? You got to take the inverse of this. And when you do so, you're going to get 25 as our total resistance. So in our notes, total resistance is going to be less than the value of any individual resistors. Or sometimes the easier way can be find the least or the lowest common factor between them. So
Okay, so sorry, the video is getting very, very choppy and laggy, so I'm just going to do it via this way. So yeah, we had our equations here. Besides a few little rule changes, everything else is going to be the same. You're still going to use the triangle to solve for select variables. So the first thing you want to do if you have a parallel circuit like this, you want to find the total resistance. So you're going to do 1 over each of the individual guys. And if you decide to do that and get a decimal, you have to do 1 divided by that decimal to get your final answer. Or what you can do is if these resistors have, all right, well, lowest common factor. You want to find you can find the lowest common factor between them, which in this case would be 100. So you can leave these two guys the same because they're already at the 100. But to get 50 to 100, what do you have to multiply it by? 2. And then, so the 50 also needs to become a 100. So when you do that, you're going to add the numerators. So 2 plus 1 plus 1 is 4 over 100. And again, because we have to take the inverse, you flip it. So when you flip this, it's 100 over 4, and that's going to give you 25. So either way, guys, you get the same answer. And then what I would show in the video is I draw the table out. VIR, we have 1, 2, 3 resistors. So we go 1, 2, and 3. Then we have RT. The stuff right here in the black is the only stuff that we were given right off the rip. 50, 100, 100, and the 12-volt battery. So I decided to, right, so everything in the red we didn't have yet. Everything in red we didn't have yet. But we did find this guy here, this 25 ohm as our RT, or REQ, and we put that down here. So then we pretty much, right, if we did that, we only have, we don't have these guys right now. So the only column that we have 2 of the 3 variables in is the total. So what you do is what? Look at the triangle. To get I, you would do V over R, but you're in the total column, so you have to do IT would be VT over RT, just like we've done, all right, using the triangle. You throw that in, you're going to get 0.048 amps. Cool. So then I put that in there. Well, in a series circuit was awesome because what we used to do is we used to just say, okay, well, once you figure out the current anywhere, it was the same everywhere. Not in a parallel circuit. But what is the voltage. So for each branch here, the voltage is going to be 12. So we know the total, we got 12, 12, and 12. And then you're only missing these pieces of information, I1, 2, and 3. So to find those variables, you're going to do, all right, your voltage of V1 divided by R1. You get this number, V2 over R2 to get I2, V3 over R3 to get I3. And then add them together to make sure that they wind up equaling the total. Okay, so pretty much once you do this, I and V were kind of swapped from series. Where I used to be the same, well, here voltage is the same. And instead of finding voltage drops, we're just finding the current through the different branches. Okay? So with all of that being said, the next thing that we are going to wind up doing is going to these little exercises here, these brain genie things. They're cool. They're great. So in these things, whoops, excuse me. This is good, guys, because this has simulations for us and we can practice. All right, this little video kind of just walks through essentially what I did, very, very quick pace without a full-blown example problem. But the exact equations are here. IT is equal to I1 plus I2 plus I3. It's the sum of all the currents. The total voltage is the same for each resistor. And then we have to do, all right, our RT equation. So then we go on to the next thing. Okay, so this is still looking at my other one. But what are they asking me for in this problem? What is the voltage through this 20 ohm resistor? So you find the 20 ohm and you're like, all right, I have this, but damn, I don't know. Well, if we went back to our equations, the total voltage is equal to the voltage going through V1, V2, etc. So guess what? What is the battery voltage? The total is 60. So that means we are going to have what? It's got to be 60. What is the voltage going through this 25 ohm resistor? Well, what is the battery voltage? It's 15. What is the voltage going through the 50 ohm resistor? What is the battery? 40. Good. All right, which one is, what about the 50 ohm or 30? Either one. Guess what? They're all going to be the same, and it should be 40. Hell yeah. Okay, the 25, it should be this 15. Cool. All right. Wow, we're continuing on. Cool. So let's get rid of that one. And then let's go on to our, yes, thank you. We know I'm presenting. Now if we go into the other ones, let's try this guy. Nope, that was one we just did. Let's not do that one. Let's do this one. Okay. Continuing practice. All right, so we need to figure out what the current is for this 50 ohm resistor. Okay. Well, for this guy, what we know if we call this R1, R2, and R3, right? So R2 is 50 ohms. What is the voltage going through the 50 ohm guy? 40. Okay. So if we want to know the current going through resistor 2, if we wanted to know the current going through resistor 2, all right, using the triangle, we would do V2 over R2. We already know this is 40 volts. And what was R2? R2 is 50. So we're going to do 40 over 50. And you can just throw it into the calculator. And that's 0.08 or 0.8. And all right, that would be amps for current. And so let's see if we get it right. Hell yeah. Okay, what is the current through this guy? Well, guess what? I think this is the exact same one, but we have 40 volts going through here and 50 ohms of resistance. V over R gives us our current. So 40 over 50, again, that would be this 0.8. All right, what about the 6 ohm resistor? How many volts are going through that? 40. And so the resistance is 6. So if we wanted to know that guy, right, we'll call it I1. So it would be V1 over R1. We said 40 volts. And the resistor value was 6. So 6.6 repeating, or 6.67 amps. Let's see where that answer is, and we're going to do that. Bingo, bango, bongo. Okay. What about this dude? What's the current, or what's the voltage going through all the branches? 15. It's the same as the battery. Good. Okay. So again, to find current is V divided by R. So V through each of these branches is 15. So I'm going to do 15 divided by 12. All right, if we do that in the calculator, 15 divided by 12, we're going to get 1.25. And then you get this dude over here, 60 volts. What is the current going through the 50 ohm resistor? I would do 60 divided by 50. And I can get an answer here of 1.2. Okay, so now we have those pieces. And then I want to do this last MacGyver here for the total resistance. So guys, this is, everyone should be trying these. All right, looking at these to make sure that you're able to do this so we can get our assignment that we're starting next done. So here, what is the equivalent resistance in this circuit? Okay, so we only have 2 resistors, right? So just somebody remember for me, 3 and 2. So our equation is total resistance is equal to however many resistors you have in parallel. So in this one we only have 2, and those ones were 2 and 3. So remember what we can do with these. You can decide if you want to do it in the calculator, right? Like do this, get a decimal plus parentheses 1 divided by 3, close it. You're going to get like an answer in a decimal, and then you have to do 1 divided by an answer. But if there is a common factor between the two, sometimes it doesn't quite work out like that, but this one does, and so that way it might be just a little bit easier. What is the lowest common factor that these two guys have? 2 and 3 What's the lowest common factor? 6? Yeah, 6 looks good. Okay, so what times 2 is going to give me 6? 3. So I have to multiply this whole thing by, all right, so top by 3 and bottom by 3. Okay, how do I get this guy? Yeah, got to multiply, all right, this by 2, and then multiply this by 2. So then you add the tops together, and you leave the bottom. Now you have to flip it. So you're going to have 6 over 5. And then you throw that into the calculator. 6 divided by 5 comes out to be 1.2 ohms. And that would be your equivalent resistance, your total resistance. 1.2 ohms. Bang. Okay, what is the equivalent resistance here? We have 30, 50, and 30. 30, 50, and 30. Okay, so someone remember those numbers real quick for me. 30, 50, 30. So R1, 30 plus R2 is 50 plus R3 was 30. Okay. So do these guys have the lowest common factor between these guys would be what?
10? No, 2.
No. You have a 50.
5?
Like multiple of each other. I don't know, I guess the lowest. So like 30 could be what? Like 60. When you times this by 2 is 60. Times it by 3 is 90. Times it by 4 is 120. Times it by 5, it's 150. See what I'm going for?
Yes.
So the lowest thing that these two guys would share would be 150. So what times 30 would give me 150? 5. So I multiply both top and bottom by 5. So I would do 5 over 150 plus 50 to 150. What do I multiply that by? 50 times 2 is 100. So 50 times 3 would be 150. So you're going to multiply the top by 3 and the bottom by 3. Do the same thing over here, which would be just like the guy in the front. Okay, so then add the tops. 5 plus 5 is 10, plus 3 is 13. The bottom stays put. Okay, you're going to get this, but now we're going to flip it. So you're going to get 150 over 13. So we call it 11.5 or 11.53. Let's see what they have here as our possible answers. Yep, 11.5. Let's try that. Correct. Bang. We already did this one. Nope. What about this guy? All right, this one, we have 3 of them, and they're each 10. So for this, we would do 1 over 10 plus 1 over 10 plus 1 over 10. What's beautiful about this one is they're all already, like, the denominators are already all equal. So we can just go skip, trying to find the lowest common factor and just go add the tops together, which is a 3, bottom is a 10. What do I do here? I flip it. So we get 10 divided by 3, which comes out to be like 3.3 repeating. And 3.3, let's try it. Okay, great. So with our assignment, you guys are going to click on this. And so inside this Google Doc, when it loads here, so inside the Google Doc, you have like these little stations. Normally, like if this was normal, I'd have little like these problems drawn across the room, and you have to go to one, solve it, get the right answer in order to go on to the next one. But we don't have that option right now. So you have these circuit diagrams, and they're only asking you to find the total resistance. So just like what we were doing, find total resistance, and then in the Google Doc, or I'm sorry, in the Google form, you make sure you have your first and last name. So like circuit number 1 goes with station number 1. Now, if you get, it will tell you whether you get the answer right or wrong. Okay, right off the rip. So if you don't get it right, it's going to say try again. All right, and you're going to go through and continue on. So circuit 2 goes with station 2. Now circuit 3, I said right here, just use the first decimal in your answer. So this would be number 3. So this is 3-1. 3-1. 3-2 would be 3-2. And then you see it has 3-3A, 3-3A, 3-3B, 3-3C. They correspond to these guys, finding the currents. And remember, the currents are as easy as going through and solving, right? Once you have the total resistance, which you already need to find, and the total current, then you're basically just filling out this guy. Remember that the total voltage here is always the same as the battery for parallel like this. So this is all 12. You already know all the resistors, so you can just divide out to find the currents. Okay? So guys, that is going to be what you are completing today. That is going to be your goal, your assignment.